Alright, Wednesday, this is week 4. Students did the pre-assessment on the chapter on dynamic routing, and then we talked about it. First thing we talked about were static routes and reviewed some of the issues and things we had concerning static routes. And then we started talking about dynamic routes, using routing protocols. We emphasized the idea to pick the best path, put the best route in the routing table. Okay, whether we're using static or dynamic routes, we need the best route in the routing table. Dynamic routing protocols, we have 4 major areas. We talked about these briefly. We talked about RIP, EIGRP, and OSPF. Protocols that allow routers to use this software to build the routing table. We can classify dynamic routing as interior and exterior. Interior routes, these are all interior routing protocols. Exterior, we talked about different autonomous systems communicating, like we used the example in class, Walmart communicating with Berkeley fishing gear, 2 big networks that need to exchange information within them. And you don't necessarily use a routing protocol, but you could. But exterior routing protocols, like the internet. Next major classification is a distance vector or link state. Distance vector, the router only learns the information from the routers next to it. So a router would indicate that it has a route somewheres, and then this router can use that information to determine whether it sends something to that router or not. Link state has a map of the whole network. So the example we used in class, if you needed to get to Eagle Grove, distance vector would say drive to Clear Lake. When you get to Clear Lake, there would be a sign there that says drive to maybe Clarion. When you get to Clarion, there might be a sign that says drive to Eagle Grove. Even though that might not be the best way, that'd be distance vector. Link state would be, you would take a map. You'd look at the map and you'd chart out the best way to get there. So both of those are used. The first 2 up here, RIP and EIGRP, are basically link state. OSPF, those are basically distance vector. Those are distance vector. OSPF is link state. And we learn the specifics of those later on. Another topic, classful and classless. Classful and classless. Classful addressing, we reviewed TCP/IP, Class A addresses, B, C, and D. And these were just some examples that we posted based on those. Routing protocols were first designed, like the first version of RIP, to be classful. They would use the class borders, and they wouldn't send the subnet mask with the information. Classless routing protocols send the subnet mask, and we're moving towards classless addressing in the world. Third thing, once we need to decide, how is it going to decide what's the best route, it can use a metric. And we only list some of the metrics here. It might be how many hops, or it could be bandwidth, it could be how much delay there is in the network, cost, and lots of other things we might add there later on when we talk more specific about metrics. But it's going to use some metric to decide what's the best route to put in the routing table. Distance vector routing. These initially, like RIP, uses hop count. EIGRP uses a variety of ways of determining it. OSPF uses a cost value that's based on bandwidth. As an example, while the routing protocols are determining the best path, we would say the routers are working towards convergence. Once they converge, which means all the routing tables have the necessary routes in them. The routing protocols kind of sit off to the side and wait for either something to change or to have a timed update. Once the routers reach this point, we say they have converged. Okay. Next thing we did some subnetting. We started with this address for the first lab. We needed at least 20 hosts and at least 7 networks, so we drew the line here. And then we started creating the networks. This would give us 30 hosts. This will give us 8 networks. Calculated out the first network and calculated the subnet mask, which the router needs in order to be able to determine which part of an address is a network and which part is a host, so it can look it up in the routing table. We wrote out the first set of addresses. We did 3 more networks, wrote out the addresses for one of them. So we have this information. Plus we did some other work on the labs, and that's it.